So with today's presentation, we are going to have a look at scaling GeoServer in the cloud or not in the cloud, to be honest. We are just going to have a look at the clustering technologies which are available. My name is Andrea. I work for an international company called GeoSolutions. We have offices in Italy and the United States. We are an engineering-heavy company that supports, actually participates, as core developer in a number of open source projects, and we provide a number of services around them. We believe in open source, in open service specifications, and well, that's why we are here at this conference. So, introduction. In terms of running in the cloud or not, GeoServer is not cloud native. It hasn't been built for the cloud. GeoServer was there when the cloud was not a thing. But it can be ready for deployment in the cloud, and we do it every day. We have blob storage support, COG. We can store tiles in blobs. We can connect to the same databases that are in the cloud because, well, they speak the same protocol as the traditional databases most of the time. There is a GeoServer cloud project specific for Kubernetes deployment with a microservice architecture. I'm not going to cover it because I don't know it, to be honest. I haven't had a chance to look into it. And there is a dedicated presentation that Gabriel gave yesterday about it. And I invite you to look at the slides for that presentation to cover specifically the GeoServer Cloud downstream project. Let's talk about clustering, which is the focus of this presentation. OGC services are mostly stateless, which means that they don't carry state between one request and the other. Each get map or each get feature and so on. They are independent of each other. Few exceptions which are related to the few asynchronous request support, WPS async request, importer async request. In these cases, there is a need for some cluster awareness. There is some state to be carried around, but it can be kept in separate databases, relational databases of your choice. So you don't really need to cluster GeoServer just because you are using asynchronous request. So there are clustering plugins, but do you need them? Most of the time, the answer in our experience is no, you don't need them. Hello, hello? Yeah, okay. So, in our experience, the most common use case is a static configuration case. In the static configuration case, you have a back office environment, also known as test or staging, where you set up the new layers, you design styles for them for optimal output and optimal performance. You set up metadata, descriptions, whatever you need. It's typically a long process, it's an iterative process. It takes some time. Eventually, you test everything carefully before going live. So before presenting new layers to your users, you typically test them carefully. When you're ready, you move the new configuration to the production environment, which is completely static, besides the few times, once a week, once a month, every hour eventually, where you have to make it reload the configuration. And at that point, the production environment is just easy to maintain. You can auto-scale it as you see fit. Nodes can go up and down without particular problem. And for the asynchronous request, the share state is in external databases. So this model is simple, has no moving parts when it comes to clustering, and it's the use case that we use the most. In putting things together, we typically version control the data directory. So we have a checkout in the back office where everything gets configured as needed. It might take whatever time it takes. Then you commit, check out in the production environment, rolling reload, there you go. You have your new configuration, which, as I said, has been properly tested and evaluated before making it available to end users. There are a few things you have to pay attention to when you are setting up a cluster of this kind. You have to keep data separate from configuration, and well, we are partially to blame because the configuration directory of GeoServer is called the data directory. And people often get confused and think that they need to stick the data into the data directory. Actually, no, for a proper production environment, you keep only whatever is static in the data directory, and you keep out of it data, logs, and tile caches. Keeping logs outside, it's easy. You can decide the configuration of by configuration delocation or by environment variable delocation. Keeping the tile caches outside is also easy. There are environment variables. You can configure your blob stores to point to S3, Azure Blob, whatever you like, or even an external file system directory. There is one thing that you have to keep in mind. This model with the rolling reload has a rolling reload time which is proportional to the number of layers. So if you have only a few layers, it's a matter of seconds. If you have tens of thousands of layers, it might be a matter of minutes, depending on how fast the drives where you store the data directory are. And typically, you want to store at least the data directory on small, fast SSDs because of that. Tile cache is a separate problem. There are common ways to deploy it. The one that goes the most in that we see at our customer sites is not something we promote personally, it's something that we find. In GeoSolutions, we typically are called after the fact. The customer has already a production environment going, and they ask us, okay, what I need to do to make it better and blah, blah, blah. This is the situation that we find most of the time because it's kind of the most obvious. GeoServer and GeoCache integrated as usual, eventually multiple of them, a shared file system in the middle with the front-end cluster populating tiles as it goes. This approach has some criticalities. Shared file system, network shared file systems tend to be fragile against large amounts of concurrent writes. They do absolutely fine with large amounts of concurrent reads, but when you start writing on them for multiple nodes at scale, they can crash or they can degrade in performance very significantly. So in this case, there are workarounds. For example, several of our customers do off-site seeding with a separate Docker machine that they just spin up for the seeding of a new tile cache. When it's ready, they slip it into the shared file system. And with this, you have a single sequential write large, which NFS typically handles very nicely. And you solve most of the problem. If you do it properly, the front-end cluster will only have to seed the few tiles that are missing, and typically it doesn't cause major problems. If instead you are in a heavy write environment, there is another solution which is inefficient from the point of view of storage and computation, which is to give each node its own separate cache. Of course, there is no sharing, so the same tile will have to be computed for each node that needs it. But because there is no sharing, everything works at peak performance. Typical use case that we see, weather forecast organizations tend to gravitate towards this. They have very short-lived caches anyways, because, well, the data keeps on updating over and over, but they want to be very fast at serving, so they typically have a memory cache and a local file system with a local tile cache. It's trading performance and sharing for better stability. Option 3, have a separate GeoCache in front with a load balancer in the middle and the GeoServers that only do map production, and then the GeoCache in front will take the map, slice it, cache it, and return the tiles. This gives best performance when it comes to seeding, because you can spread the seeding over multiple machines. The GeoServer ones are the ones that are actually doing the heavy lifting. The GeoCache has its own dedicated file system. And what's the downside? Well, you have to do double configuration effort. GeoServer has its own layer configuration. GeoCache has its own separate XML tile layer configuration. Keeping the two in syncs can be annoying. You can use the REST API if you want to automate the configuration of the layer in one side and the other at the same time, which is often what people using this model end up doing. It would be nice if geocache could just read the configuration directly from GeoServer, but we don't have a module for it available in the GeoServer project. It's a good idea. If you want to fund this development, we are all ears. Okay, let's say that you cannot do static. You really need to change stuff configuration in production. Well, I'm going to try to convince you that you really don't. In our experience, most of the time, you do not need to change the configuration in production unless you are structuring your data in the wrong way. So, typical use case. I receive new data continuously. New satellite images, new position of ships, new this and that. Well, if your structure of data is regular, just use dimensions to filter the slice of data that you need in WMS or SQL filtering on the fly, and just use one layer that you filter dynamically based on this dimension. As new data comes in, you typically window. So you register new data in your whatever data structure you're using and come into it, and you probably delete all the data, but your layers stay the same. It's the dimension attached to the layers that do change. So times, elevations, runtimes, and so on. And you don't really need to touch the configuration. You just need to touch the registration in the database of the data slices that you add and remove all the time. To do that, you use mosaics or partition database tables. So for images, image mosaic store with PC stored index table, and you just keep on hitting that table. In GeoServer, the layers remain the same, and the problem is solved. And then you send a time filter, a SQL filter, to get out the right image that you want. We do it for proper time management, but for example, there is a website containing historical maps of all the United States, which is called historicalmaps.com, I think, that uses a single GeoServer with a couple of million images, which are completely unrelated to each other, all stuck in a single, in a few image mosaics, and they just keep on adding images to the index, and that's it. The configuration never changes. If it's vector, well, you can do database tables. If they grow too big, you can do partition vector tables on PostgreSQL. If they grow even too big for that, when you start reaching the hundreds of millions of records, there is a new plugin called Vector Mosaic Store that works just like the image mosaic. So you have an index pointing to your geopackages, your shapefiles, your flat geobuffs, eventually stored in S3. Only the flat geobuffs are cloud native and you can store them on S3. The others you store on the file system. And again, you choose your slice of data, and GeoServer will to pick the file and render it or serve it. So again, there is no need to add one new layer for each and every dataset that's coming in, as long as the structure is uniform. Let's say that different users need different views of the data. Well, okay, you just need to filter the data. It could be done by a SQL filter from your client, or you can manage it with security and just attach different filters in a geofence rule, for example, to restrict what they can see by area, by alphanumeric content, and so on. You don't need to set up a different layer for different users. You just need to have one layer and dynamically filter it based on the current user. Maybe you have clients that have limitations. They cannot do time in WMS. They cannot do proper filtering in WFS. Maybe they don't know about the GeoServer extensions like SQL filter. Okay, in the community section, there is a parameter extractor module that can be used to trick this client into doing dynamic filtering anyways. It allows to configure an extraction of a parameter from the path, which you can add freely, and this module turns it dynamically into whatever extra parameter you want. In this case, I'm taking H11 from the path and turning it dynamically into a SQL filter. I can give this to ArcGIS, and ArcGIS will use SQL filter without knowing what it is. Okay, let's say that you really, really need to change the configuration in production. I haven't convinced you. All right, then, typical use case, you are allowed your users to upload the data to your server, and then yes, this situation has different different structure for each any new layer that they upload. They are responsible for the configuration of the new layer. They will take their time. They do it right after the production system. Hopefully it's going to be many small data sets, because if you allow them to upload a massive data set which is not properly configured, then it's going to be trouble. But let's say that this is the use case. This is a valid use case that we see. And then, well, we haven't seen any other valid use case among our customer base, but I hope that someone will tell me what other use cases are actually requiring dynamic configuration changes in production environment. So, for those cases, there are two clustering community modules. Community modules are unsupported modules that you can get out of the nightly builds. One is called JMS clustering, another is called JDBC clustering. They work on slightly different principles. They share one thing. There is not enough traction on either of them to have a dedicated maintainer. JMS clustering is maintained by GeoSolutions when we have a need for a customer, which doesn't happen often. So, for example, for the past 6 months or more, it wasn't working anymore because of a change in access stream. We didn't notice because we don't have any customer using it, or at least in the version where it broke. And eventually someone told us and we fixed it, but for 6 months it was unoperational. JDBC clustering has a couple of sites that we know are using it, but again, no dedicated maintainer. There is a couple of developers that every now and then contribute changes, and that's it. So, not enough traction. So, and apparently they are going to stay there. JMS config works by message passing, by means of JMS. There are different possible topologies, but the idea is that you make a change in one node, it sends a JMS message to a JMS server, which spreads it to the other nodes, and the other nodes are applying it and synchronizing themselves to the main configuration. The JDBC config case instead uses a shared database, and basically it doesn't load the configuration in memory, at least not a startup. And when it needs to find the configuration of a layer or a workspace or a style, it queries the database. At the beginning, it was probably without any sort of caching, and it was way too slow. All the queries done by the data to the configuration database were actually slower than the map building and so on. Eventually, they added caching, and then you have to add another plugin called HZ cluster that basically spreads around messages that, hey, this layer changed, please drop your caches, because otherwise you have stale information. Okay, I did some testing of the two modules. I took the AnyStyles repository, which is a natural earth styling done in CSS. It's a political map, it's dense enough to be real. It's actually slow at some scales. And I did some WMS load testing with vanilla/JMS config versus JDBC config. Vanilla and JMS are pretty much the same. Configuration is always kept in memory. JMS just spreads messages to update the in-memory configuration. JDBC config is different because it's talking to a database, at least some of the time. I made two cases. Case A, any style as it is, which is just 25 layers, so a small configuration. Case B, I duplicated the workspace a number of times until I reached 40,000 layers, which is sizable. I took a build of a few days ago, as you can see, so it's the latest information that you could gather. And then I did my own load testing with the classic 2, 4, 8, 16, 4 concurrent clients doing randomized WMS request and so on. This is the result. JDBC config is typically between 10 and 20% slower than vanilla, which is, in my experience, a great improvement, because when I tested it 2 years ago, it was a lot slower. A lot slower when there were many layers. It was like 50% slower than the vanilla case a couple of years ago. So something changed that made it faster. Startup times with the 40K layer, JDBC config does not load anything, so it's just 13 seconds. It's basically just starting up GeoServer and all of its internal facilities. Vanilla JMS, the startup time is proportional to the number of layers. In my case, it was 56 seconds, with data stored on a fast, very fast SSD. I know that in GeoServer Cloud, which is, as I said, this cloud downstream project, there is a new config loader that could do better than that. It's parallelized in a better way, but it hasn't been donated back to the main project yet. We look forward to that. I also tried administrative access with the 40K layers case, and this is where JDBC config is doing really, really poorly. I tried to access the homepage. With JDBC config, it takes 72 seconds. With the vanilla case, 1 second. I tried to access the layers page as an admin. With JDBC config, 5 minutes. With vanilla, 2 seconds. So JDBC config and the user interface with many layers don't play well together. If you have few layers, no problem. If you have many layers, it's unusual. Okay, the future. Eat your cake and have it too. So, we made a few considerations. Reality check first. GeoServer was built over 20 years with the assumption that the catalog is in memory. The code expects that it's really quick to get any configuration from any layer, eventually multiple times during the same request, because it's in memory, it's instant. And get the full list of anything, all the layers, all the spaces, all the stores, all the styles. It's a fast operation, which is not the case when you are storing the configuration outside of it. So it makes it hard to have any solution based on external storage when you have many layers. Reality check number 2, there is a small amount of deployments that actually need dynamic configuration changes in productions, and core developers are actually busy maintaining the GIS part of GeoServer. So we need some plugin that is basically keeping up with whatever happens in core without any extra maintenance, because we cannot dedicate much time to it. So what we are going to do in the next few weeks is to prototype out an Hazelcast-based distributed memory catalog. Hazelcast is a library that we have some experience with in large data deployments that has distributed data structures, distributed logs, messaging, and native integration with various clouds. So the idea is that we are going to use the same XML serialization for core messaging that we use for storage in the data directory, because we already maintain it. We don't have to, duplicate any new messaging system. We just have to write whatever we would write in the data directory, and declare the data structures as distributed maps in Hazelcast. Hazelcast allows for a near cache, which means that the map is distributed, but it can be actually fully duplicated in every node, and it does the work for us. I change the content of a map in one node, the other nodes see that immediately. And in the meantime, it can also distribute the queries. It also has native integration with AWS, Azure, and Google Cloud. So the idea is that we are going to go this way in order to have a minimal maintenance, high performance clustering plugin that we can keep up over time. So summarizing, using most of the time you just need to use the static data directory, share, load balance, and auto scale. If you really need to change the configuration, the answers right now are JMS cluster or JDBC config. Right now they are both working. We put the JMS cluster back in working order. Moving forward, we are going to try and prototype out this new plugin that hopefully will allow us to keep it up with low maintenance cost and a good performance. And that's it.